All right, we're going to solve some systems. System has two equations, and we want to know what x and y pair would solve both of them. So it's like the x is when the solutions are the same, and the y is what solution is the same, what value is the same. Substitution is a technique that's especially good when you have one of these equations solved for either x or for y. Like in number 42, y is negative 5x minus 1. So in math, we're saying these are the same thing. They're equivalent. Just like 3 is the same as 2 plus 1. That y is the same as negative 5x minus 1. So in the second equation, when I see a y, I can substitute negative 5x minus 1. And know that it should also be equal to 9x plus 27. Once you get here, you just have to solve. So you need to get all the x's onto the same side. So I'll do that first. We get negative 1 equals 14x plus 27. Now that all the x's are on the same side, we need to move the 27. So there are 27 on the right. We have to take away 27 or subtract. We get negative 28 equals 14x. And then we divide by 14, we get x equals negative 2. So that is the solution for x. We still need to know y though. Y is equal to negative 5x minus 1. Well, before we didn't know what x is, but now we do. It's negative 2. So we get y equals 10 minus 1, or y equals 9. So the solution to this system is the point negative 2, comma 9. When x is negative 2, it makes both of these equations equal to 9. And that is what it means to be a solution for the system. All right, if you jump to number 43, it's just slightly different because they're not both solved for y. So there's a little more algebra that you have to do. You still are going to take the 3x minus 1. What it says is the same as y. And you're going to plug it in for the y in the opposite equation. So you'll have negative 8x minus 7 times 3x minus 1 is equal to 7. Then to solve this, you need to do a little distributing. Negative 8x minus 21x plus 7 equals 0. Negative 29x plus 7, whoa, it's going to equal 0. It doesn't equal 0 yet, sorry. This should also be a 7. Got ahead of myself a little bit. So then we subtract 7 from both sides. We get negative 29x equals 0. And then some people panic here and there. They think that there's no solution, but there is something we can multiply negative 29 by and get 0. 0. So if I divide by negative 29 on both sides, I find out that x equals 0. Okay? And that is most of the problem, but now we have to go back to the original equation that says y is 3 times x minus 1. Now that we know what x is, we can plug it in. We get y equals negative 1. So the solution to this system is 0, negative 1. All right, now let's solve one by elimination. The way we solve by elimination is we are trying to take one of the variables, either the x's or the y's, and make them have the same number but the opposite signs in both equations. And so we're going to add the equations together and line them up, add them straight down, top to bottom, and eliminate one of the variables so that we can solve for the second one. So what that looks like on number 45 would be, or 44 would be, you'd have to multiply the bottom equation by 2 so that the x's would have the same coefficient. So negative 4x plus y equals 18. Haven't done anything to that equation. But if I multiply the bottom one by 2, I get 4x minus 6y equals negative 28. Multiply every single term in that equation. When I add these equations together, negative 4x plus 4x is 0x. Y plus negative 6y is negative 5y. 18 plus negative 28, or 18 minus 28, is negative 10. We get y equals 2. Just like before with the other system, we should plug that y in to one of the previous equations. Doesn't matter which one, and we should solve for x to find the rest of the solution. But I just wanted to show you that before jumping into 45, where it's a little more difficult to make them have the same coefficient. So if I multiply 3 by 3, I get 9, and I still won't be able to eliminate the x's. 7, it's hard to turn that into a 10. So what I am going to do is look for a least common denominator between these two things. So if I multiply 10 by 2, I get negative 20. Can I multiply 3 by anything to get 20? No, as far as integers are concerned. But what if I multiply the top by 3? That gets me negative 30x minus 30y equals negative 90. So what can I multiply negative 3x by to turn it into not just 30? So if I make it into 30, I'll have to do something a little bit different. But if I want it to be a positive 30, I need to multiply it by negative 10. I'm not subtracting 10, I'm multiplying that whole thing by negative 10. And it gives me a positive 30x plus 70y equals 170. And that allows me to do what I did in number 44. I can add these equations to each other. The x's will cancel out, meaning they have been eliminated. Negative 30 plus 70 is 40y, and it's equal to 80. Divide by 40, and interestingly enough, we get again that y equals 2. And that's not the full answer, so I'm going to go back and plug this into the first equation. Negative 10x minus 10 times 2 equals negative 30. So negative 10x minus 20 equals negative 30. I'll add 20 to both sides, solving for x here. I get negative 10x equals negative 10. Divide by negative 10, x equals 1, and the solution is 1, 2. All right, one more time, let's solve a system. This time by graphing. We want to see where these things are going to, where will they intersect on a graph? So that's where the solution is always the point where these two lines intersect. But for this one, we're actually going to use that as the method of solving. So it's always the point where they intersect. We just haven't been looking at the graph to see it. I need them to be set. I need them to be solved for y. So I'm going to divide this whole first equation by 9, because 9y divided by 9 is just y. Negative 45 divided by 9 is negative 5 plus 10 over 9x. If we graph that, we start at negative 5 on the y-axis. Then we go up 10 and to the right 9, or forward 9. And it's very difficult to connect those lines on this thing, but I'll take it. Now we need to do something similar for the other one. So it's negative y, it's not y, it's negative y. So how do we get rid of a negative? Well, we can divide everything by -1, or you can multiply by -1. Same thing, either way. We are going to essentially just flip all the signs. Y equals 2 plus 1/3x. So the y-intercept is 2 on this one. We go up 1, forward 3, up 1, forward 3, up 1, forward 3. This point should not be there. It looks something like that. And the place where they intersect one another is that point right there, the point 9, 5. All right, we'll call it quits there for systems. We will jump into systems of linear equations. We'll jump into some different kinds of systems, look at some graphs in the future videos.